Hello Gladiators, let's look at our Unit 1 test review. Our first section is classifying real numbers, 7.2a. So if we look at this table, we want to place a check mark for all the classifications that apply to the values in the table. So let's go ahead and look at number 1. We have 7500ths. If we look at 7500ths, that could be classified as just a rational number because it's a fractional part. Natural, whole, and integers cannot have fractional parts. If we look at number 2, we have a -8. So if we look at natural numbers and whole numbers, they can only be positive, and then a whole number can include 0 as well. Integers can be negatives without fractional parts, and if you check integer, then we need to check rational number as well, because all integers are rational numbers. Let's go ahead and look at number 3. If we look at number 3, we see it's a negative, but let's go ahead and divide that. It's improper. So 6 divided by 3 is 2. So this is actually -2. So if we think about what -2 would be classified as, again, it's a negative, so it can't be natural or whole. It does not have any fractional parts, so we know it could be an integer, and if it's an integer, it's also a rational number. So if we look at numbers 4 through 6, we're going to write each element in its most specific set or subset on the Venn diagram. So if we look at this, we have -9 for number 4. So we see it's a negative, so we know it can't be natural and it can't be whole. So now we look, it does not have any fractional parts, so we know it can be an integer. So -9 would go in the integer section. So let's look at number 5. We have 1/4. So this is a fraction, so it cannot be natural, it cannot be whole, it cannot be an integer, so it is a rational number. 6, we have 16/2. Again, this is improper, so let's simplify it to see what we get. 16 divided by 2 is 8. So let's look at the number 8. It is positive, and if we look at natural numbers are the counting numbers which are positive and does not include 0. So 8 would go under natural. But if we look at 8, 8 is also whole, it's an integer and a rational number. However, we're putting it in the most specific set or subset. So let's go to number 6. Number 6 states, what is the best classification for -4? So let's just think about -4. Let's think, can it be a natural number? No, it's negative. Can it be a whole number? No, it's negative and it's not 0. Can it be an integer? It can only be an integer if there's no fractional parts. And this does not have any fractional parts, so this is an integer. Also, we can say that all integers are rational numbers, so it is also rational. And then all integers and rational numbers are real numbers. So let's see which choice has all 3 of these. A says it's irrational. Well, that's not true, so we can definitely cross out A. B, we have integer. Yes, it's an integer. It's a rational number. It's a real number. Looks like that's our answer, but let's just make sure. Let's look at the rest. C, it cannot be a whole number because it's negative, so we can cross out C. D states it's a rational number. Yes. It's a real number. Yes. However, it's missing integer, so D is incorrect in terms of having all the classifications. So B would be the best classification for -4. So let's go to the next problem. Here we have set A has numbers 1, 2, 3, 4. Set B has -5, -3, 0, 2. We want to circle all the sets, so circle all the sets that would fit in both set A and set B. Well, let's look at set A and look at what type of numbers do we have here. And let's think about the best classification. So we have 1, 2, 3, 4. Those are positive. There's no fractional parts, and I do not see 0. So the best classification would be natural. So these are natural numbers for the best classification. If we look at set B, we have -5, -3, 0, and 2. Well, we have negatives, so we know the best classification cannot be natural or whole. And we have a 0 and a 2. So integers would be the best classification for this set because we have negatives without fractional parts. So when I look at these two, the sets that could go with both have to meet the criteria for the most specific set that we're given. So set A would be the most specific, meaning it has the least amount of numbers that fall under it. So if we look at A would have to fit all natural numbers. So 8/4, 8 divided by 4 is equal to 2. So we have 2, 3, 8, and 13. Are all these natural? Yes, there's no fractional parts, there's no 0, and they are all positive. So A looks like one of them. So let's look at B. So all these are improper fractions, the first 3. So 6 divided by 3 is 2. 16 divided by 4 is 4. 16 divided by 2 is 8. We want to simplify to see what we get before we decide to classify. So 2, 4, 8, and 20. So again, they're all positive. There's no fractional parts. There's no 0. So all of these are natural and integers. And again, A, all of these are natural and integers. So B looks like another choice. Let's look at C. We have 0, 5, 10, and 15. So they have to meet natural and integers criteria. All of these are integers, but there's something in here that's not natural, and that is 0. So because there's 0 there, it only fits the integers classification and not the natural. So C is out. Let's look at D. We have -10, 0, 10, and 20. So here we have a negative. Natural numbers can't be negative. However, it is an integer. And 0 is also is an integer and not natural. So D is out because it doesn't fit both natural and integers. And the only two that fit both are A and B. And it asks us to circle all the sets. So A and B are both natural and integers. So that concludes section 1. So make sure if you have any questions about this section, make sure to ask your teachers. Have a great day. Bye-bye.